Why do we see condensation in thermodynamics? Have you ever wondered why your cold drink sweats on a hot day? That phenomenon is a perfect example of condensation in action. So, why do we see condensation in thermodynamics? Let's break it down. Condensation occurs when a vapor, often water vapor, loses energy. This energy loss usually happens through cooling or compression. When the vapor cools, it reaches a point called the saturation point. At this stage, the vapor can no longer hold all the moisture in its gaseous state. As a result, the molecules slow down, come closer together, and form liquid droplets. To understand this better, let's look at the basics. Condensation is a phase change from gas to liquid. In thermodynamics, this change involves energy transfer. When vapor condenses, it releases latent heat. This releases of energy aligns with the first law of thermodynamics, which tells us that energy is conserved. The energy lost by the vapor appears as heat transferred to the surrounding environment. The second law of thermodynamics explains that this heat flows from the warmer vapor to the cooler surroundings. This flow of heat drives the condensation process. Now let's talk about the dew point. This is the temperature at which air becomes saturated with water vapor. When warm, moist air comes into contact with a cold surface, like a glass of ice water, the air near that surface cools down to its dew point. This cooling causes the water vapor to condense into liquid droplets on the surface of the glass. Several factors influence condensation. First, temperature plays a key role. Lowering the temperature reduces the vapor's ability to remain in a gaseous state. Next, pressure can also impact condensation. Increasing pressure forces vapor molecules closer together, promoting the change to liquid. Humidity is another important factor. Higher humidity means more water vapor is present, increasing the likelihood of reaching saturation. Lastly, condensation nuclei, which are tiny particles like dust or aerosols, provide surfaces for vapor molecules to cluster and form droplets. In thermodynamic systems and cycles, condensation is essential. For instance, in refrigeration systems or steam power plants, vapor is compressed and then cooled in a condenser. During this process, it releases heat and transitions back into a liquid. This liquid can then be reused in the cycle, demonstrating energy conservation and efficient system operation. In summary, we see condensation in thermodynamics because vapor loses energy, typically through cooling or compression. This energy loss leads to saturation and the transition into liquid droplets. Understanding this process helps us appreciate both natural phenomena and engineered systems involving gases and phase changes.